This is a program I made that simulates a laboratory creating card designs and then sending those card designs to a factory which generates cards out of those designs, and then the factory choosing which cards from that list of cards they created from the designs to send to the store based off of demands from the population and disposable income amount. And then the store selling these cards and then getting the final profit between the factory and the store. Um, so we're gonna go through the main first. So we just have some stuff here. Welcome to my factory. How many days would you like to witness the simulation? We input the days. We get the days from the user, so that's how many time steps it's gonna run. We create our objects, the lab, the factory, um, the demand, the seller, and then we go ahead and we obviously we don't need to create instances of an object here because these are generated inside of these. We have our stack ID, which is one that we'll get more into that. Each time step, a stack of cards is generated, so this increments. We have our random engine for some generation of the data for the cards. And then we get to our loop. So the loop, basically the first step of the loop is we create our designs. We create a stack of card designs in the lab. Then we go to the factory, we get that stack of cards, and then the iterator for that, because we have to create a new object called final card, which I'll go into that too. We get the randomized demand from the population, and then we choose which cards to send to the seller based off that demand. And the seller copies the list of cards that are to be sent, and then the factory erases the cards that have been sent to the seller, and then a seller time step. I'll go into that. That's essentially just selling the cards, keeping track of the profit, and we increment the stack ID, and that's it. We display our info, and that's the main. So I'm gonna run the program. So we are going to run it for, let's say, we'll do 5 days. So let's go to the top. So these are the card designs from lab. So we have rare cards, which are all right here. Their value, their stack ID, which keep in mind. So these are generated during the first time step. These are during the third. This was during the fifth. The type, which is random, A, B, C, D. And then the rarity, which is rare, uncommon, or common. Our uncommon cards are right here. We see the values and stuff. And then the common cards are right here. You see the values. Obviously, you can see that a common card is worth significantly less than an uncommon card. And then a rare card is worth a lot more than an uncommon card. So this is the designs from the lab. So we go to the factory now. All factory lists. Cards waiting to be sent to the store and cards sent to the store. Cards to be sent, so to sell cards. So these are cards that need to be sold. All of these. To store cards. All of these. So these are the ones that haven't been sent to the store yet but need to be sent. And then 20 cards have been sent to the store so far. Go to the store data. These are the current shelves, the current cards on the shelves in the store are these three. And the sold cards are all of these. So this is a list of cards that have been sold to the population. You can see that this has been set to sold. And we have our total profit for the store, which is, all of the value of the cards minus 3 because of factory. Each card that is purchased from the factory for the store costs $3. Factory's profit is 60, and that's the program running. So let's go into the files. So first of all, a card, we just have the data ID, value, type, and rarity. There's no sold variable yet, which that comes later on in final card, because these are designs, not cards. We just set our constructor to some basic stuff. We have a display here that displays the value, the ID, the type, and the rarity. So we go to a card stack, the next level. So basically, this one's a little bit more complicated. We have a function here that is called genStack. You see we have these included here. We include card, list, random, and C time. So it takes in the stack ID because that's going to be used to put the ID for each card in the stack, and then the default random engine pointer. So let's take a look at that first. So GenStack is right here. You see all the data in here is just lists, so there's nothing to really put there. So take the stack ID and the pointer. So we have these random machines here to get values for the data of a card design. Basically a 1 in 15 chance of a jackpot, which means that the card is worth $100 extra. Rarity, there's a 1 in 7 not 1 in 7. Yeah, there's a 1 in 7 chance of the card being rare. There is a 2 in 7 chance of the card being uncommon, and there's a else down there for whatever's left for being common. So there's a higher chance of being common than uncommon, and a very rare chance of being rare. 1 in 4 chance for type gen A, B, C, D. And the amount each time step is 4 to 8 and random. So we get this stuff, we run a for loop where we create a card and we run some stuff here. I'm not going to get fully into it because this is pretty basic. It's just if else statements based on the default random engine to set some stuff to, setting the values rare. We add the card value as well as we go in here. So A is worth 1, B is worth 2, C is worth 3, D is worth 4, and if it's rare, it's an extra 100. If it's uncommon, it's an extra 10. If it is common, it's an extra 1. And then if you hit the jackpot, an extra 100 on top of that. So we set all this stuff here. We go down here, we set the rarity, and then we push into the stacks. Uncommon stack, common stack, and then down here into the all stack. This is important. So we go back here. You see we have these lists. These are just for displaying purposes, right? But this list is everything together. And that's why we have these displays here just for displaying stuff. And we get down here, we have a function that returns all stack. So basically this function is going to return this entire list, and we're going to use that in main. And then this returns the iterator for this as well, because we're going to make final cards out of these card designs, which have an extra data point, which is sold. So let's get to that. So we have all these displays, just pretty basic right here. Take a second and read this if you need to. So that's it for the card stack. So if we go back to main, if you remember, this is the first function. So we generate the stack of card designs. We go here to copy list. So let's go look at that. Lab. So factory is what the object lab is in main. So we just have profit sold cards. We have a list of cards to be sold, and then we have a list of cards that are ready to send to the store based on the population demand, and then we have the iterator. So and here we have our gets and sets for the ends. We get down here, we have a function that is called copy list. So this is where the function from card stack and this get together. So it takes as a parameter the all stack and then the iterator, and what it does is, we'll take a look at it in here. Copy list is it takes those in and it sets an iterator to the beginning of all stack, which is passed in, and then we create a final card, which is right here. Let's take a look at the data for this real quick. So we have our exact same things, just an extra variable string sold. So it's basically the same thing, except for this is actually the card that is ready to be sold. It's not a design, which is just that it's actually got an extra variable for that. So we go ahead and we set the stuff from the design, and then notice we don't set the sold, because in the constructor for final card, sold is set to available by default. So we push that into the to sell cards list, which is in the factory, and then we go on to the next card and we iterate through this list, which we get from here, the iterator, and we basically copy the entire list into real cards of cards that are basically we just get all the cards from the lab, and we put them in the factory and create real cards out of them. So these are all real cards now after this. So This is just a display. It shows the cards ready to sell, and it shows a list of cards that are to be sent to the store. So if we go down here, it's erase cards. This erases all the cards that have been sent to the store. But we haven't gone through the choose function yet, which is where this comes into play. So let's go back to main. So if you see this, the next step is the demand, randomized demand. So if we look at population, this is pretty easy. There's only disposable income. I have it called disp money, and then type influence, which is should be a character, but I have it as an int because I was lazy. So basically, the only function here is this. Basically, we randomly generate a 1 in 4 chance of which type the population is favoring that day. So A, B, C, D, 1, 2, 3, 4. And then the income is between 20 and 200. Say it lands on 20, only $20 worth of cars would be purchased by that population that day. So the factory only sends $20 worth of cards to the store to put on the shelves. And that's also if the type of cards that the population is wanting that day aligns. So we generate that, and then we just set it equal to these in the main. We do that each time step here. Then we choose the cards here. So this is where that function I was talking about comes. So go back to factory and choose cards. So it takes in the population demand. So we get the type influence. We put it in this int val. And then we get the disposable money. So this is the max amount of money they can spend. We create a character and we just do this. This is why I probably should have just done a character inside of type influence, but it's okay. It's okay. And we just do what I should have done inside of population here. We iterate through the list of cards that are to sell. And then if the type matches the pop demand and the disposable income is greater than 0, then we go ahead and we send that card to the store list. And then disposable income gets decremented by the amount of money the card is worth. And then sold cards, increment, profit, plus equals 3, because each card is worth $3 that the factory sells. Each card sold by factory worth $3. And then we erase from the list of cards to sell the card that is now in the list of cards that are ready to be sent to the store, and we iterate. So that's it for the factory. So if we come back here, we now go to the seller, which is the store. So we get the list of cards from the factory that are ready to be sold. So if we go back here, get list, all we do is we return send to store, which is a list here of cards that are ready to be sent that were chosen by the choose. So we basically get that there. Let's go to the store. The only things we have in the store are shelves, which are cards that have not been sold yet, and then cards that have been sold to the population, a profit, and a card sold amount. So the function copy list takes the sent to stored from factory, and it basically sets shelves equal to that. So essentially, the shelves are just cards that are ready, basically sent from the factory. Each time step we run that. So each time step we have a new set of shelves, and then we erase from the factory the cards that are now on the shelf in the store. And then a seller time step occurs, and let's take a look at that. It's in here. No, here. All right. Time step. So it just iterates through, and if gets sold is not equal to sold, because obviously if a card is already sold, then we don't want this to run again. We'll just get like duplicate values and stuff. It'll be bad. We set it to sold if it's not already sold. The profit gets increased by this, the value minus 3 because the factory's money. We push it into the sold cards list, and we erase it from the shelf. So that's basically it. This is just a display, just shows the data. And if we look at final card, I don't think I've gone over the functions here. It's basically the exact same as the regular card, except for this is added and this is added, and that's the entire program. And let's run it again. Let's run it for like 10 days just to kind of see. I just finished it before I made this video, so I'm kind of debugging as well. Maybe there's an error in here somewhere, but the overall code should be right. Maybe a logical error somewhere or fallacy, but I think it should be good. It's just so many copying and erasing that I just hoping I didn't mess up somewhere. So designs from lab. We have rare cards, uncommon. This should be no problem here. 2 cell cards. I'm hoping I'm erasing from this list. When I put them here, I'm pretty sure I am. Let me run it for a lower amount to kind of check that. 2 store cards. So deck ID 1, 102, type B, rarity, rare, available. So maybe I need to erase from the 2 cell cards. Am I not doing that? Let's look at factory. It should be. Let me run it again. Let's try 1. Oh, it's because it hasn't been sold yet, that's why. So it should all be right. Current shelves. Let me see, the 2 cell should not have this. 2 store. Okay, that actually makes sense. I was getting confused. So the profit is 0 because it costs $3. All right, I got myself super confused. Current shelves are empty because this has been sold. Total factory cards sold has been 1, so that makes sense. 2 cell cards, 2 store cards. So this should not be here. Let's check. $3. It doesn't look like it's there. So it should be working right. It's just I don't have enough variance in the data of the cards to where everything kind of looks a little confusing. So 13 should not be there. 13 stack 1. 13 stack 3. Type C. Rarity. Alright, yep, looks like it's all working right. So that should be the end of the video. It's just me going over the code. Hopefully it makes sense, and I hope there's no errors there. And if I catch any or someone catches any watching this or reading my code, feel free to point them out. I didn't really do this super in depth. It only took me about a couple hours to make. So feel free. But that is all, and goodbye. Thanks for watching.